Okay, hello everyone. Welcome to Room B. Just a couple of things, especially as we get to the Q&A session. Make sure to repeat all questions that you hear, especially for the moderators up here so that the Zoomers can hear. We are going to have somebody that is going to be joining from Zoom to give a talk. So we'll have a little bit of a period to unmute the TV and mute the microphone so there's not a crazy thing going on. But really excited for all the presentations today. So Jeff, take it away.
All right, thanks everyone for our second day. And so kicking things off in this session, loosely themed around wildfire smoke and wildfires themselves so our first speaker is Jingqiu from University of Alaska Fairbanks, giving us the perspective of Boreal fires. Thank you, Jeff.
All right, so I proceed. Okay, thanks everyone for coming to second day. Today I'm going to talk a little bit about the Boreal forest fire, which is apparently quite different from what you guys have in lower 48. That's what we call continental US, lower 48. We actually have lots of fires there, and I'm going to talk a little bit about the gas, which is from formaldehyde, and the particulate matter emitted from Boreal forest fire, and we're trying to do something with remote sensing. So I'd like to introduce my team, including my president, Tian Zhao. He has been working on this quite a bit, including Ichi. Jen is also working in my group that she's also going to start working on wildfire. And we have Jun Wang from University of Iowa and hired from Navy Research Lab. And we have a bunch of stakeholders from Department of Environmental Conservation and Alaska Interagency Coordination Center, AICC, and Alaska Fire Science Consortium. Here you can see Tina is sitting next to Pandora, which we have running for past 3 years. Okay, so the first thing is talking about formaldehyde. Actually, originally we were trying to use that to understand biosphere atmosphere interaction. So we set up a framework. We use GSChem nested grid model, and then we use NASA ATOM-1 aircraft campaign during Alaska period and the flight, and we also went with MaxOS ground-based measurements, and then we compare with TropoMe measurements, and then try to understand formaldehyde variability and the source in Alaska. And then what we found is really interesting is that here I'm just jump to results quickly. First of all, is that if you look at the first row, this is TropoMe DVCD. Basically, this is signal has been seen from TropoMe for formaldehyde in Alaska, and the second row is what we did from model sensitivity test. Is basically it's model showing formaldehyde enhancement due to wildfire. We can see some strong signal in the center Alaska. Okay, the first row is May, second row is June, and third row is July, and the fourth row is August. Our fire season is from June to July. It's basically the fire season. We do see some strong signal in the center of Alaska, and then if you look at the third row here is formaldehyde enhancement due to biogenic VOC. It's rather weak. And then we did some budget for the emission, and what we found is that biogenic, despite it's emitting a whole bunch of a lot more VOC from vegetation, it's really making a very weak signal. On the other hand, we found that wildfire actually you really have like 1/3 of the 1/4 of emission, but you make a much stronger signal. The reason for that is because there are actually strong emission, direct emission of formaldehyde from wildfires. This is quite different from biogenic VOC that will require lots of chemical reactions to take place to make formaldehyde. It takes a while. Also, you need NOx, which we do not have much in Alaska. So it's therefore making formaldehyde very, very inefficient. And then this here, I'm just showing you one low fire year. Then I'm going to show you a little bit about strong fire year. This is for 2019. We had a very strong fire year. And this is a very different story. So for strong fire year, here I'm showing you the first row is TropoMe data that from May, June, July, and August. And the second row is from GSChem, nested grid simulation. We can see that GSChem can very well reproduce the spatial and temporal variability of formaldehyde VCD. So this is a vertical column density, which we use to quantify the formaldehyde, and it's amazingly well. And the model got a very good agreement with TropoMe observation. And this is real signal I've been seeing from TropoMe. And so from our source attribution, we find that the majority of this signal is actually from wildfire. So indeed, that when you have strong wildfire year, you have lots of formaldehyde directly emitted from wildfire. That contribute to the majority of formaldehyde in Alaska. This is something could be also useful to start thinking about formaldehyde in lower 48. Once there are a lot of fires, formaldehyde from wildfire can be a very strong signal that should not be ignored. So we do some calculations that we found that for this year, that when we have like a little bit more emission of twice emission of wildfire, the signal of formaldehyde VCD is about 10 times higher than biogenic VOC. This is for the year of 2019. So biogenic is very weak. Again, the reason for that is lack of NOx, and it's not making much. And the direct emission of formaldehyde is very strong from wildfires. Okay, so right now we are trying to set up a network for Max DOAS network for ground-based network at different NEON sites called National Ecological Observatory Network, and we got set up a few Max DOAS sensors there, and from there hopefully we can develop some comparison between Pandora, Max DOAS, and Tropomi in Alaska domain and try to understand biosphere and atmosphere vegetation. My second topic is that is about aerosol optical depth and surface PM 2.5 relationship. That's I think was being discussed yesterday. This is a plot to show that our current idea about how we're gonna understand the AOD and PM 2.5 relationship during fire season. And I think Yang Lu has shown some interesting results, and we are also doing a little bit different, taking a different approach here. Is that we first of all we use model. Just kind of model to calculate this relationship, AOD and PM 2.5 relationship. Here I'm showing you again these 2 years from May, June, July, and August. And for 2008 and 2019, 2018 is a weak fire year, 2019 is a strong wildfire year. And here we're trying to relate surface PM 2.5 with AOD for any location specific relationship. We use that data to describe that. As you can see for 2018, you do not see much color, and 2019 see lot more color. And the reason for that is because the relationship is very much dependent on intensity of wildfire. And when you have wildfire, the eta is much higher, and when you do not have wildfire, eta is much weaker. And this relationship is only in the model. We don't know if that's true or not. So then we compare that with observations. We have observation from MODIS, from WIRS, and from surface PM 2.5 measurements. And what we found is that here I'm showing you a distribution of this relationship at different AOD conditions. If you look at the leftmost panel, that is showing you at the different AOD conditions that when particularly I want you to focus on the red line when AOD is high, the slope, the eta is getting much higher. But then if you look at middle panel, which is the observation constraints AOD and PM 2.5 relationship, that does not show this increasing trend of eta of this slope. So here, if you look at the right panel, here is showing you that at different AOD condition, how model relationship and how observed relations look like. You can see the blue line is observed relationship at different AOD. The observed relationship does not increase. But in model, the slope actually increases with AOD, which means that you're gonna have higher slope while you get higher AOD. So then we start use CADIOP compared with GeoSTEM during fire season, and this is kind of busy plot. Sorry about that, but here we just trying to look at when we have higher slope and higher AOD, then how model and the CADIOP Calypso data look compared to each other. So what we found that this is something consistent with what Baron and I think Taiwan's group has shown yesterday, that when you have strong fires, high AOD, model tend to have much more particulate matter in the surface layer. And this CADIOP does not show that. This blue dot is from CADIOP Calypso data, do not show this strong surface accumulation. The reason for that is in GeoSTEM, we do not have a plume rise model. And so we just, when we have stronger fire, we just dump everything to the surface, it's kind of accumulated. But in reality, it's maybe when you have strong fire, it's gonna have higher elevation, you have more injection heights, and therefore maybe fire plume will go up higher, and therefore this relationship has shown stronger discrepancy when fire is stronger. So this is consistent with what Panelists group has shown yesterday. When you have stronger fires, the prediction is getting worse and worse. We think that's in part due to the injection height. Okay, so we did a correction, and for that, and then eventually we were able to. I'm just gonna go to the. Now we have corrected PM 2.5 AOD relationship. We can reproduce this. Well, reproduce the surface PM 2.5 concentration, and we are also using this relationship to give a model derived satellite derived PM 2.5 compared to purple air. We found it's also agree okay with purple air data. We hope this can provide a mean to calibrate purple air for special many cents for special network of purple air. This is something we're hoping to do in the next couple months. And for last 1 minute, I will just quickly just show one thing. There's a new network called atmospheric science chemistry measurement network. This is a new network, has been had chosen 12 sites, about $12 million, and they're gonna do lots of measurements. And here's a site map for different sites. We in Alaska, we are one of the sites being chosen, and so for 12 sites together, we're gonna make lots of real-time aerosol composition measurements. And the instrument includes aerosol mass spectrometer. We're also gonna measure aerosol size distribution and measure metal concentration and measure aerosol absorption and the brown carbon. So in the next couple of years, there's gonna be a whole new data set for aerosol composition in real time. This can provide a new dimension for aerosol pollution. This is something hopefully that will be of interest to all of you. With that, thank you very much.
So we're going online now, where Daniel Tong from Georgia Mason University should be presenting the next talk.
Right. Daniel, just give me 1 second. I'm gonna make sure we're.
Good morning, everyone. Sorry, I
1 second, Daniel. What I'm gonna do here is we're going to mute or unmute the TV.
Okay. All right, I'm trying to share my screen. Can you see my screen now? All right. Hey, good morning, everyone. I hope you are all enjoying the meeting. So today, I just want to give some updates on the team's work on the health effect of the 2000 Western US wildfires. And it's a work from a large team, including from Young News team and also Georgia Mason and NOAA. So just give you some background. Some of you are probably already familiar with this. And this was one of the largest wildfire season in record, only over the United States. And we have seen, never seen so many fires and also burn in such a short time. So on the left was the Ghost 16 imagery, and on the right, and that's showing the FRP, which is mostly proportional to the amount of emission emitted by those fires. And you can see that in 2002 is not only the largest, have the highest bar, but also you see this off season, which is in the red from August to October. You're seeing this very high portion for that in a year. So this is really extraordinary. And there are several questions being asked. One is what are the health air quality effect, and or what is the health consequences for that? So last time we reported on the air quality effects, and this time we're going to focus on the health consequences of those fires. So how do we quantify the health effects? We started with air quality effect. So that's we use the air quality, the wildfire emissions. That's use the blended Moody's and Veils fire product, and provided by Shuba and Xiaoyang's group. It's called GBBX. And we're also using two CMAX simulations. One is with fire, and another one is without fire for the entire year of 2020. And this is configured with a full chemistry with detailed anthropogenic emissions and natural sources, including windblown dust. And for fire emissions, also a big concern is the plume rise. So because we want to simulate the 2020, and that's it's based on a fire radiative power. So that's the best, the current plume rise scheme in CMAQ is based on bricks require the heat flux. So we implement a new plume rise scheme called SOL5 2012 into CMAQ. On the left is showing the VIRS observation. VIRS is just like Moody's, but it's on the newer satellite. So we are gradually switch to VIRS right now for the model evaluation. And the center is the CMAQ simulation of AOD. You can see that AOD from Moody's, for VIRS, and also from CMAQ pretty much simulate the spatial pattern on that. We also did a comparison of surface PM2.5 because Jingqiu just showed earlier that the relationship will vary, right? So on the left level is the AOD, on the right is the surface of PM2.5, and the circles on the right panel are the EPA monitoring data. So you can see that over the Western US, and there's a very high PM2.5, and on the eastern part of the plume, where even you see high AOD from both satellite and also on the simulated AOD from CMAQ, you are not seeing the high surface concentration. That's because the particles are very efficient to absorb sunlight, but the mass concentration may not be high because the particle is very tiny, and also the particle can be staying aloft, it's not coming to the surface. So this is a quantification of the impact of wildfire emissions on surface of PM2.5. Here we are showing during the fire season, which is from August to October, we are seeing this high contribution over the western coast and also on the southeastern US. Southeastern US pretty much dominated by the agricultural burning. On the lower part panels are showing the percentages. So during the fire season, the entire Western US was covered by more than 50%, contributed by wildfires. And if you average it out for the entire year, it's about 20 to 25% for the Western US. So we did we calculate the contribution ratio, which is use a very simple formula. It's the simulation with fire minus simulation without fire. Normalized by the with fire case. So in the Pacific coast, we're seeing the largest impact, which is not surprising because they are close to the fire source region. The contribution can come up to 80% for some days. And for the Mountain West, it's come to 70%. On the average, nationally, we have about 25% from wildfires contributed for the entire. I also noting for the over the United States. So what is the consequences for the ecosystem and what is consequences for humans? Right, so this is a work led by my colleague Patrick Campbell. His paper just published in this week. He calculated the ratio of nitrogen deposition to the critical load for the major vegetation types. And I'm showing here on the right is the major types we have here. For example, the mixed forest, grassland, crops, and also inland water. For the California region, we can see that without the wildfires, you can see that most of it, the critical loading is 1 or below 1, and not much above 1, except in the Central Valley, right? Because where you have a lot of agricultural activities. Then with fire, that's a huge increase in both in the near the source, which is you're seeing the highest impact on the critical load, but also the downwind areas. So the largest impact we are seeing here is over the mixed forest. The difference is about 170%, which is not surprising because you can see a lot of ashes covering the forest after the wildfires. But we are also seeing that wildfire impacts is disrupting other ecosystem, the grassland, the cropland, and also the inland water. very significantly. So I will switch gear a little bit to talk about the health effect. And this work following this traditional method, basically we try to put the concentration change and link that with the concentration effect coefficient provided by Daniel Gross's 2009 paper. And then this is based on the county. This work has been done by Yang Liu's team. So we provide the concentration, and then we link it up with the beta value, and then also the baseline mortality estimate for each county, how many excesses of mortality have been caused by the wildfire exposures. So in 2020, we estimate that wildfire PM 2.5 exposure led to 22,000 deaths, excess deaths, and that's about 8.8%, 0.79% of all cause of deaths in the continental United States in that year. So next, we want to ask where are the wildfires and who are facing the consequences during this fire season. So the red dots here are the satellite derived fire emissions. You can see that for some regions, they have more fires and also large piles. Piles is proportional to the amount of emission emitted by certain fire case. And we found that the largest number of deaths occurred in the Los Angeles County, which is number 6 cause of deaths in that year. And but the per capita impact showing the largest impact in the Santa Clara County, where the Silicon Valley is. They have more than 1/3 of all cause deaths are contributed by wildfires. So this is not surprising because they are close to the fire sources. However, even you are living thousands of miles away, for example, this is the Cook County where Chicago is. We also calculated more than 100 deaths. If you remember the transport pathway of those wildfires, you can see that Chicago, this metropolitan area actually sits right next along the pathway. So they are one of the counties seeing the largest impact. And even you stay 1,000 miles away, you are not free from the harm. So lastly, we just want to do a comparison of the economic cost of those wildfire health impacts compared to other fires. One of the most comprehensive study was done by Neil Fund of EPA. They studied 5 years of fire exposure, and they exposed both the short-term PM2.5 exposure impact and also the long-term impact. So it's one of the most comprehensive ones. They estimate that about 2,000 deaths from short-term exposure, and more than 8,000 and sometimes up to 14,000 people died from long-term PM2.5 exposure. And their economic cost is about from $10 to $20 billion from short-term exposure, $76 billion to $130 billion from long-term exposure. For the 2008 California wildfires, the one and all study showing that more than 3,600 premature deaths that costing $32 billion. And they consider both the medical costs and also the work time lost. In other cases, mostly we are just looking at the mortality impact. But the mortality impact is the largest one, the majority of the one. And Australian big fire was in the news, but they are only costing $400 million. It's much smaller for that because they are mostly grassland, and then also the population exposure was much smaller because of sparse population, and also much of the plume was transported over the ocean. And then compared to the last one is our study here. It's 22,000 deaths, which is twice as much as the highest number that was studied by the EPA study. So and then this cost is the average was $220 billion. So this is much higher than all the other studies because both the fire intensity was higher and also the duration of exposure. So why are so many fires in 2022? In 2020, there are several theories have been proposed. For example, people think that anthropogenic climate change is basically increasing all the fire chances. And also for that time, there was fire fuelable weather patterns, and that's fueled by the decline Arctic sea ice. That's by the PNL study led by Zhou et al. And also there's a study showing that the 3 Western Pacific typhoon is the hurricane in the Pacific Ocean, strengthens the fire weather, which caused the teleconnection in the Western US. And our group did this study showing we think the most effective way to showing the correlation was look at the dew point depression, which is defined as the difference of mean temperature minus the mean dew point. So here we are showing the 2020 here. It's the highest one here. If you look at the correlation, it was very high, 0.774. And then also the second largest is 2020. If you look back the fire radio power we showed earlier, 2020 was the highest one, and 2012 was the second highest one. So obviously the drought currently going on also it's going to cause a lot of problems for us in terms of wildfires in the future. So this is a take-home message. We access 22,000 excess deaths caused by the wildfires in the season. And indirect cost is much higher than the direct cost. And the climate and weather conditions are behind those fires. With that, thank you for your attention.
So next is Mary Yule from the Western States Air Resources Council, talking about Western wildfires.
While he's getting that going, I'll explain really briefly what WESTAR is, Western States Air Resources Council. We are a council of the 15 Western states from Alaska. If you can imagine, I always look at it this way, like from Alaska down to New Mexico, from the Dakotas to Hawaii. Those 15 states, the state, tribal and local air quality agencies within those states, the federal land managers, and EPA. We get together on a regular basis and talk about air quality in the Western United States. We also collaborate in areas where states are interested in doing so. And most recently, I think we've been talking a lot about wildfire smoke in the West. Let's see, is it just a picture? Yeah, okay. So Western air quality. This slide, I've been using this slide for a little over a year now, and I've been adding headlines, and it's getting kind of crowded. I probably need to eventually clean this up, but for me, it sort of illustrates what's going on in the West. Things have obviously are deteriorating. We saw with the latest American Lung Association report, I think 25 of the most polluted cities, or the cities with the worst air quality, are in the West now. Hardly any of them, hardly any cities in the East are as polluted as the cities in the West are. And some of my headlines are from New Mexico, where my office is. Of course, this has been a rather eye-opening spring for New Mexico as fires continue to burn there. So, what happened to my slide here? Part of it's missing, but that's okay. All right. So these are some of the things associated with wildfire that Western state, local, tribal air agencies are dealing with. Of course, wildfire smoke, the smoke from the fires, probably most important, but international transport too. If you've been looking at satellite data, there's a lot of fires burning in Western Mexico right now, and those combined with the plumes from New Mexico. And those plumes are really transporting smoke across the country. The long-term drought and aridification of the West, we're seeing more and more dust storms in the West. And of course, that's a result of climate change. Mobile source emissions are becoming much, much more a prominent part of the emissions inventory in the West, as a lot of coal-fired power plants have shut down, and then states dealing with exceptional events so that we're not trying to resolve national ambient air quality standard violations that are predominantly caused by wildfire smoke. This is some work that Westar did on the 2021 wildfire season. It was such a wildfire smoke was really dominating state air quality across the West, and we wanted to know exactly how many exceedances of the national ambient air quality standard states were recording. And as you can see, the number of monitor days, that's the number of days at each monitor that exceeds the standard. In July, in region 8, which is the Intermountain Western states, we were seeing over 1,400 monitoring days. And I think the West got sort of a break this in 2021. We didn't have the bad October through December wildfire that sometimes we see, but these sorts of numbers are sort of unprecedented. These are really large numbers of days that we haven't seen before. I like to quote the state of Nevada, where they said in the months of June, July, and August, they saw no monitored days that met the ambient air quality standards. So, and this is just putting that a little bit in a different way, separating out by pollutants. Of course, 5,319 days impacted at the monitors, where we saw above the national ambient air quality standards. And then for PM 2.5, that was 2,832 days. And for ozone, 1,820, and of course, PM 10 as well. So in the long term, after states, locals, tribes deal with the very immediate public health impacts, informing the public, communicating with the public during a wildfire smoke event, there's this other process that starts for the states, and that's flagging and analysis of that monitoring data, flagging the data that has been affected by wildfire smoke. There's an initial process, there's a concurrence process with EPA, and then there's this determining regulatory significance, which happens sometimes years beyond when the data has been flagged, a couple of years at least after the event often, and consulting with EPA. So if a state does determine that there's some significance to an exceptional event, that's when the process of submitting the demonstration starts. And that means, does that event affect whether an area would be attaining or not attaining the standard? So states aren't submitting exceptional events demonstrations for thousands of days yet, but we have heard some Western air agencies are looking at, for instance, 80 to 100 days from last summer that could be regulatorily significant, particularly in California. And then there's EPA action on the submittal, and then more recently we've seen there's the defense of that submittal when there's a court challenge, and the state of Arizona went through that last summer. The court deferred to the expertise of EPA in the state in actually an ozone exceptional events demonstration that the state had submitted for the Phoenix area when it was affected by smoke from a California wildfire. So this is a very complex and I would say like it will be more time consuming for the states as they wander through this process in coming years because of the amount of wildfire smoke in the Western US. I'm going to leave you, well, no, this is not my last slide, but this is, oh, it's kind of cut off there at the top, but this is the US Drought Monitor. This is for May 24th. And as you can see, we've got a lot of extreme drought in the West, a lot of exceptional drought. If you look at last year, you see very similar, maybe slightly lesser patterns. And so my takeaway here is that likely not a lot changing this year for the West, and perhaps not next year as well, because we're looking at a three-year likely another year of La Nina conditions in the West that are favorable for more drought, more wildfire in the West. This is my last picture. This is actually not too far from my house. And that is the Calf Canyon Hermit's Peak fire that's been burning in New Mexico. You know, just you know, the impacts of the fires. I would say you can see this is actually from a friend's property. And it was actually on a day where he had a number of folks out. He was trying to make some progress on clearing his property should the fire come closer. The fire is about 10 miles from his property there. But at any rate, in New Mexico, you know, this spring, I think we've seen really, you know, certainly a collaborative effort. Forest Service and the National Weather Service has done a great job with the air quality alerts. A lot of that aided by all the years of wildfire in the West and all the research that's been done. So that's it for me.
Last but not least, HAQAST Ambassador Perennial Michael Geigert from the Connecticut Department of Energy and Environmental Protection, and using satellite data for air quality forecasting and analysis.
Okay, basically, well, you've been introduced to me, and shout out to Daniel Tong, who couldn't be here. He talked about the 2020 fires. This is about 2021, and basically, I'm going to show the end button, right? No? Oh, okay. All right, there we go. And basically, air quality forecaster analyst. We write the SIPs for state of Connecticut. So basically, we have the worst air quality East Coast. And now, you know, since I've been in HAQAST, we've been using satellite data quite a bit for our forecasting, almost a daily affair, in fact. And I just have a few of the options we have. The NASA Worldview is very helpful. That mostly the polar orbiting satellites, but they have added the geostationary satellites as of last August. So if you can find it on there, it's 10-minute increments. So it's very good. And also Aerosol Watch is very good because it has a lot of PM products and other things. So, and it features VIIRS in the geostationary satellite. So it works. Okay, good. And her smoke, because as a forecaster, basically we have to look at models. Satellite images are great for what's coming, but as you know, her smoke has been used by the media outlets quite a bit. You'll see it on TV. They'll say, oh, here's the smoke across the country, especially last year. But you'll look at the illustration on the right. There's the her smoke, and that was for May 22nd, for instance. And there's a satellite image on the left. You can see the visible smoke, and they usually line up pretty well. So we've grown to use her smoke quite a bit, and we've been in touch with the developers, and we asked them to put some cross sections in, and they're very helpful. And the cross sections, like I highlighted in the middle here, shows a cross section. You can see on the top, it went from like Chicago to Boston. It just shows the height. So there's another tool the forecasters can use. if it is correct. Okay, so what I have to show you is July 2021. Daniel Tong talked about the year before the mega fires, but for us, July 2021 was the mega fire year for the East Coast, Northeast. Now, this is the vertical integrated smoke. I'm using the HER smoke model because it did very well. And of course, the satellite, you see a lot of clouds in the satellite images, but this is pretty good for showing the trends. This goes all the way to August. So basically, we were hit pretty hard in July. I'll show you why. And we had actually 2 smoke events in July 2021. We never get really big smoke events in Connecticut, right? I mean, usually you have to be pretty close to the wildfires. Well, actually, we didn't have to be that close. These wildfires were 1,000, 2,000, 3,000 miles away. There was wildfires on the West Coast in Canada. And so I'll look at those 2 smoke events. But the worst one was on July 26th. And the satellite, we were tracking it with the satellite, and but we were using HER smoke, and HER smoke kind of let us down. And here are the images for July 16th when I got started. Aerosol watch on the left, you'll see it shows some of the PMs in the readings in the circles, but it shows the fire and the FRPs sort of over Canada, Western states. You'll see the smoke, and then world view I have in the center panel showing all the fires in Canada, and you'll see the smoke. And that's how I got started. Oh, here it is. The animation is working great. On July 19th was the day before. Look at the intensity of that smoke. I circled one of the sources up there above the Minnesota border. Minnesota got really hit by this smoke. There were fires out west, but it was really these Canadian fires that brought the smoke to the Northeast states. But you can see it almost went down to the southern states. I mean, it was so intense. And here's what it looked like on July 20th. Look at the extent of that. The 2020 fires, we saw huge smoke plumes also, but like I said, this is the one that really impacted us the most during July. You could just see, I mean, the hazy skies, a good deal of the country was hit. And then if you look at the hourly PM 2.5, nothing like the West Coast, you'll see values of 500, right, micrograms to 1,000. You wonder if the machine's broken, the monitor's broken. Okay, so we have values up towards 100 at our Cornwall site, for instance, but still I have the line there. The red line is 35 micrograms, our 24-hour standard. So we went over that day for the average, but I just show you the hourly values. And that's what it looked like on the national level. You can just see the extent, the yellow, just moderate PM, but some people are very susceptible even on moderate levels. And you can see the most intense was like from Connecticut to the Southwest over PA on that particular event. You can see the West Coast fires. There was some erupting in Northern California, Washington State. But look at Minnesota, that code purple. They really got nailed by that fire. And here is the one that really affected us. I mean, caught us kind of off guard. You can see the plume. I put these animations together from Aerosol Watch, and you can see that intense plume coming over Lake Huron on 26, and there's where it hit us. You can see the PM levels. I kind of like the overlays here. You can see the PM, hourly PM kind of light up. By July 27th, it went off the coast, but there were still some fires to our west, but we didn't get really hit as hard after that. So look at this July 26th. Sure, the West Coast fires, California were just erupting even more, just getting started really. But East Coast, look at that whole eastern part of the country, moderate or above generally, with the Northeast states really hit hard. In fact, Connecticut wasn't the worst on that day, but we were pretty bad. And on the 27th, we still had some exceedances, the 24-hour standard. Northwest, you can see Canada was really taking the brunt of it by then. And here are the numbers. Okay, so Massachusetts had a 24-hour value of 59, and ours were in the 40s and 50s. Now, nothing compared to the Western states, but the visibility was so poor that day, and you could smell smoke. There was a lot of interest. And I point this out, we hadn't seen this type of smoke since That was July 7th on my birthday. In fact, 2002, Quebec fires. It was a weekend. Of course, we were totally off guard because we don't forecast on weekends. We had to come into the office, but there it was. We had values up over 80 for a 24-hour standard. So that was not as high last year, but still, honorary mention, I guess you'd say. And then here's the hourly. This is what caught us off guard because you can see how fast it went up. We saw the plume coming. It didn't look that bad compared to the week before. It looked like a narrow plume moving very quickly. We said, oh, we'll get a few hours. And the model was showing it heading northwest. But look how it went from like 20 up to 140 in like 2 hours. So I have a little news clip here. Hopefully we'll play. I don't hear any sound, but what she's saying is that people were very upset. In fact, I don't know if the audio is off on this, but basically that's what it looked like over Hartford. And what happened was that people were calling the fire department saying, must be a building on fire or something next door because I smell smoke, or there's a forest fire next door. And that was the people, like the fire departments were just being lit up. They've never seen anything like this. So you can imagine these fires were 1,000, 2,000, 3,000 miles away. Okay, so, and there's the animation. This is what happened. You can see that smoke plume. You can see how it came down across Connecticut, went all the way to the coast. Now, I'm going to show you next was the smoke column. We saw that plume. See, the smoke column on her smoke was to our north. It was modeled to stay to the north. And that was the interesting thing. So we said, oh yeah, we'll get some moderate air quality. And you can see this is near surface smoke staying to our north. So we didn't expect that, but there's some LIDAR, they have some wind cubes in the New York system, and you can see the backscatter just to our west, the intensity of that plume, but you can see it was down below 500 meters. And that's what happened. Basically, it downsloped as soon as it got over the Appalachians. Now, I want to just put a shout out to RSIC 3D. I used this quite a bit before. And this is a tool. You get tropomi, satellite data. You can overlay it with PM and all sorts of nice layers. But I just wanted to show you the CO. I filtered out the CO value. CO is a great indicator for smoke, tracking smoke. I use it for exceptional events. And you can see there it is, some intense CO. It followed the smoke plume. So that's another great product for stakeholders to use. And conclusions, it just, the satellite data is just so valuable for us, in tracking smoke events. I mean, we were aware it was coming on the 26th. We thought it would stay to the north. As you saw on the satellite, it downsloped. It went into the boundary layer. It just went into the valley. It soaked into the valley. We're not expecting that. And we got caught off guard. We had to issue the alerts on the hour, basically, air quality alert. We don't like to do that, but that's what happened. So, okay, well, thank you for having me.
Yeah, we have about 8-10 minutes left since these sessions today are only an hour rather than 75 minutes. But if we can have all the speakers come up. When there are questions for Daniel, you can either comment when you want to speak to something, or perhaps there'll be questions direct to you. So.
Okay, thanks.
Yes, yep, it's still there.
All right, so looking for questions or comments. Yeah.
Hey, question for Michael. When you use first smoke, my understanding is first smoke is based on a dispersion model. It doesn't include any secondary chemistry, but it should track the core of the plume pretty well.
It should.
Does it provide forecasts, or it's just near real time?
No, it forecasts out to 48 hours for sure. Yes, it's updated. The meteorology is updated like her, the meteorological model. So that's what confused us, because we looked at the initializations for every hour during the day, and it's still the meteorology if the plume was there, it didn't get the meteorology right or something. And I point this out to the herd developers. I was hoping that they'd find an answer to this. Because yeah, once the plume is created, it's coupled chemistry, it's fully coupled, but it doesn't really change after the plume is created. So we're kind of counting on the meteorology being correct.
But I also got another question for Dr. Mo. So I'm wondering, do you mind expand on the essence network that you were showing on your last slide?
Oh, sure. Let me repeat the question. So the audience was asking a question about the ESSEN network. This is a new network, has been led by a PI at Georgia Tech, Sally Lin, and I think Ted Russell is also co-PI on this team, and we have 12 sites, 11 sites in lower 48, and we have one site at Alaska to monitor aerosol speciation and the physical and the chemical properties in real time. Every hour or half hour, we will have data point, and that data will be online soon. And we are currently setting up the site. Each site will be equipped by like 4 or 5 instruments, as I showed. And so it's going to be a pretty nice network in our opinion. And this will be long-term monitoring. So hopefully that can also provide some validation for satellite. Maybe the new satellite will be up in air that can provide more information for those kind of aerosol chemical and physical properties. Does that answer your question?
I have a question about it. So in Connecticut, do you think people locally responded before to take anticipatory action to get out of bad air quality, or do you think this was the event that may have cultured people so in the future they'll understand that wildfire smoke can impact their lives?
So the question was whether the people were warned properly if they took action about the wildfire and what we could do in the future.
Well, yeah, just whether they took it seriously or maybe they didn't, but now going forward, they definitely.
Yes, whether they would, going forward, take it more seriously. It was such an unusual event. We probably hadn't seen it in Connecticut in 20 years. So it hit all the news, and fortunately we issued the alert, but we did not issue the alert before it happened. And which was unfortunate because people hopefully would not have been calling our fire department. So in the future, if it happens in a few years, people probably will just remember that, yeah, we can get effects from Western wildfires. And I'm not sure they would take any action because I'm not sure it curtailed any of their lifestyle, but it did last the whole day and overnight. So I was home outside and I was having trouble breathing. I mean, I noticed it. So it did have effects probably on people's activities, my opinion.
So I have a related question, and certainly it's relevant for Mary too. And so, Michael, when you mentioned that you could smell it, I thought that was interesting because in Colorado, when we get smoke from Washington State or from Montana or California, we generally can't smell it because the catechol and some other chemical species that cause the smell have chemically reacted away. But when we have our local fires, you can smell it. And we anecdotally, like people I know study fire, we sometimes don't realize we're in smoke until it's hazy, and then we're texting each other and be like, why don't you check her, or why don't you check aerosol watch? And so we've hypothesized that there's this general difference between when the public who doesn't study smoke, so if I don't realize there's smoke there, unless it's like really bad, that are generally less aware and maybe take less actions when the smoke comes from a long ways away versus when you have a fire nearby, which is why, Mary, if you think about states that both get it from a long way.
Yeah, no, definitely. I think, I think probably I was actually during that July 26th, 27th event in the Midwest visiting family. And when I told them, I said, this is smoke, you can see, I can see it in the sunset. Tomorrow morning is going to be bad. And they all looked at me like, what is she talking about? That fire is like out in California, no way. And, but sure enough, watching, I think like, well, in particular, like right now, I'm watching fire.air.gov like a couple times a day. And you will see, these peaks come up pretty quickly. That said, I mean, I don't know that folks in the West are really particularly conditioned yet. You know, I've talked to people who have said, you know, oh, it's just smoking in my house this morning, so I lit some candles, and you know, and you're thinking, candles. My goodness, adding to the particulate loading in your home. But you know, to speak to the question about people like escaping, I think that's a little bit of a misconception as well, because for most people can't pick up and go somewhere, and especially a lot of people in rural parts of the West, it's not reality. And so, you know, really what you can do is sort of prepare for that mitigation by having an air purifier, or even building a box fan. You know, now we've seen, I think a lot of folks maybe have seen the instructions for taking a fan and putting a bird filter on the back of it, and those kinds of things, having that clean room in your house. But
Don't we all have that, or not, a lot of us have like
right,
massive.
right, yeah. So, but difficult in your home to continue to, you know, and at night you don't want to sleep with it at 95 on. So getting that air purifier, making sure people have a clean room, making sure people have a cool place to go to, because a lot of, you know, we're seeing more and more these heat waves in the West and the associated wildfire. People want to open the windows. There's not as much air conditioning in the West. So there's a lot of things. It's not only Connecticut people having to figure this out. It's Western people as well. There's so many more wildfires, so much more smoke now.
So Alex, should we take one more, or do you think, because we're right up?
Let's
against
do
it.
one quick one. There's nothing in the chat, so that'd be great.
I had a long one for Daniel, but
Oh, maybe that's
I'll make a short one. You know, Jingqiu, I think, made a good point about whether it's sensors or our eyes, there can be a disconnect between what we perceive, like, oh, it looks really smoky, and what the ground levels actually is. Is that also a source of disconnect you guys observed, that people have a day and like, oh, it looks really bad, but it's actually scattering light a lot more than actually the concentrations? Is this also a disconnect with public faces?
Yes, that's what I heard, that often aerosol can stay pretty aloft, and then surface chemical is okay. You know, it's not as bad as you use the linear relation to derive. It's just quite different. There are quite a bit of aerosol up aloft, and that situation has not been addressed, I guess. I heard from lots of forecaster air quality folks who are saying aerosol are sometimes can be pretty high, but I don't know what to do right now with that information, or how to get that information effectively.
Yeah, I mean, I think like states will start to hear from people in their state, even at moderate levels on the air quality index, which is not a great amount. You know, around, I would say between 15 and 20 micrograms per cubic meter on an hourly basis of PM2.5. States will start to hear from citizens in their state, and that's you know, that's considered moderate. If you look at their AQI, they'll say time to open the windows and go around walking outside. So yeah, it still seems like there's a disconnect between what we're telling the public and what perhaps some people may be experiencing, because I think, you know, where you see that unhealthy for sensitive groups, for most people, that's a kind of a difficult situation to be in for a number of hours. Maybe not for an hour, but for a long, you know, a couple of days at unhealthy for sensitive groups. You know, most people will note that they have trouble breathing, that they can't do their normal routine, even just, you know, things they would do that are moderate.
Yeah, so we're now into the time of our next session. So thank our speakers again.